All right, and so let's do this one. Okay. How many different passwords are possible? Okay, so what would we do? We got 5 capital letters from the English alphabet. All right, so you can do 5 letters. So remember I suggested, you don't have to, but I think if you have any trouble, it'd be easy just to do it, to actually do it. So I'm just going to pick one. So WXVCB. There's my license plate, 5 letters. Now think back to decisions and options, right? I made 5 decisions. How many, whoops, not PO. I keep writing PO. How many options did I have for each of those? How many options for the first decision?
26.
20, because there's 26 letters in the alphabet, huh? 26 for each of these guys, huh? Why doesn't it go down by 1 every time? When do they go down by 1? Like 26, 25, 25?
When it says you can't repeat the
When
same.
you can't repeat, exactly. When you can't repeat, because then you got like choices each time. Yeah. So that's just 26 to the 5th, right? That's B. Everybody good with that one? Next one, number 9. How many different passwords, I can't read that, start with Z, end with W? Okay, let me actually do it, because I think that's helpful. So I'm going to start with Z, and then go ABC in the middle, and end with W. All right, I actually did it. I made 5 decisions. How many options did I have? I keep wanting to put that P first. No P first. There we go. How many decisions? How many options for the first decision? 1 here and 1 there, because you had to start with Z and had to finish W, and then there's just 26 for the others, huh? So if you multiply those all together, that's really 26 to the 3rd. The ones don't do anything, so it's D. Good. We're rolling. These easy for you. Number 10. All right. A license plate. 5 letters except O, I, and Q. Yeah, we had this as a quiz question, huh? O, I, and Q. How many start with Z, end with W? That's the same thing. So Z, A, B, C, W again. You know, options. Okay, 1 and 1 because you got to start with Z, end with W. Only difference this time is you can't have O, I, and Q. So those 3 options are out. So instead of 26 options, I've only got 23 options, letters I can use, huh? So it's 23 to the 3rd. That was a previous quiz question. Easy for you. You're laughing at that one too. Good. Number 11. How many of the license plates begin with the word math? Maybe you didn't laugh at that one.
23.
Good. I like that you're laughing. It's easy, isn't it? Simple question if you're thinking right. Yeah, do you see that? So if you're all confused, what's my suggestion always? Literally do it. Do what? Pick a license. Do what they're saying. What are they saying? Pick a license plate that begins with the word math. So they mean you have math and then like C or something. Something, right? Because it's got to be 5 letters, right? It's got to begin with math. And it's got to have something at the back, right? So I just did one. I picked a license plate, 5 letters, begins with the word math, and then has something else, right? So think back to what I just did, how many decisions I made, and how many options I had for each decision. How many options did I have for picking the M?
1.
I had to pick M. And I had to pick A, and I had to pick T, and I had to pick H. How many decisions for that last spot? 20. You said it right a minute ago. Yeah, 23. Because we can't use that. We're still under the can't use OIC. That applies to 10 and 11. By the way, sometimes my tests print out weird. It's just the test bank thing I'm using from the publisher. So watch the instructions. You're like, what would have happened, for example, if 10 had been here and then like 11 had been on the next page? You know, you might read 11 and just think, not realize that these instructions applied to 11. So in other words, here's what you do. If you're ever reading a question on any page in the tests, probably should have said this back before the first test, huh? And you're reading it and you're like, what do they want me to do? Look back to the last time they gave instructions. That applies to all the problems until they give new instructions. You know what I mean? And sometimes that rolls over to a new page. It's not the best setup they have on those things. Yeah, if you're not sure, come up and ask me. I'll speak to you in code and make it more confusing. No, I'll say, I want you to know the instructions for sure. Okay, so that's it. So number 11 is just 23, huh? It's just A there. Is that good? Okay, number Okay, so let's put 4 capital letters followed by 3 digits. How many are possible? So I'm going to pick one. A, B, C, D. Is it 4? Yeah, 4 letters, 3 digits. 7, 2, 1. So there we go. So, all right, how many decisions did I make? How many options? So 26, 26. There's no limits on anything right now. 26. And how many digits? When I pick 7, how many digits were possible? 10, right? Not 9, but 10, because there's 1 through 9 and 0. So there's, right, you could put there. So there's 10 different digits possible, options for digits in each of those spots, right? They're not limiting my choices in any way right now. So multiply that together. That's going to be 26 to the 4th times 10 to the 3rd. It's A, huh? Number 13, how many Tasmanian license plates begin with 66, or end with 66? So let me do one, A, B, C, D, 4, 66. So I actually did one. Think back to my decisions and options. I had 26, 26, 26, 26 options. And then when I picked the 4, had 10 options. Could be any digit there, huh? And now when I picked the 6 and the 6, just one option for each because I had to do 66. So what is that? 26 to the 4th times 10? So B. Good? Easy, easy. All right. Number 14, how many of the license plates? Yeah, see, here's a new page. This would be like a new page on the test, huh? But it really goes back to those instructions. How many start with the word add? So let me pick one. A, D, D, and then we're supposed to have some other digit, all right, B, and 5, 7, 9, 3 digits. Okay. So number 14, we don't take the instructions from number 13 or anything. Nothing about the 66, right? Because that was just for number 13. We just follow the directions that were over all those problems, right? Okay, so I just did it. How many options? I got to start with ADD, so 1, 1, 1 for the add. And then, what, 26, 10, 10, 10. So what, 26 times 10 to the 3rd? So this is 26 times 10 to the 3rd. Yeah, so that's just 26 with 3 zeros at the back. 10 to the 3rd, right? That just puts 3 zeros, 26,000. Easy? Super easy. All right. Okay. French restaurant, 5 appetizers, 3 salads, 2 soups, 7 main courses. That's a lot of things. 7 desserts. All right. On Monday through Thursday, the fixed price dinner consists of a choice of appetizer, soup, main course, dessert. Assuming you don't pass any of these, how many different fixed price dinners are possible? Okay. So it's the same thing. It's just decisions and options, right? So let's write down what it is we're talking about here. Okay, appetizer. I'm just going to write. We get to choose an appetizer, then a soup. Just going to write them down first. Then a main course, and then a dessert. Okay, so those are the 4 decisions I have to make, huh? And for each of those decisions, how many options? So for the appetizer, how many?
5.
Yeah, 5. Right there. And for the soup, 2.
Oh, we forgot salad.
No, not for number 15.
Oh.
Yeah, so not everything's in there. You got to read just what 15's asking for. Main 7, dessert is 3. Multiply those together. Is that 210?
Yeah.
210, right? Because it's 21 times 10.
Thank you.
There we go. That good? That makes sense? I just did the ones they asked for. They just said appetizer, soup, main, and dessert. Number 16, on Fridays and Saturdays, fixed price dinner consists of appetizer, soup, or salad. Main, and dessert. Assuming you don't pass, da-da-da. Okay. So, what are we going to do? Well, we choose an appetizer, soup, or salad, main, and dessert. Okay. Appetizers, 5. That's no different. Main is still 7. Dessert still 3. Okay, but what's the super salad thing now?
5.
Yeah. You just say, well, if you're going to choose a super salad, you got 3 different salads to choose from and 2 different soups. There's 5 different options for choosing either soup or salad. You're not getting both. You either get the soup or the salad. It's 5 different options, huh? There it is. Whatever that comes out to be.
It's 5.25.
Is that what it is? The B? Thanks. We good on that? That makes sense how I did that? Soup or salad was 5 options, right? Because there's 3 salads and 2 soups. 17, 18 are hit the buttons on the calculator, right? Is that okay? I mean, make sure you know how to do that in your calculator or by hand. By hand, it's, well, I never even showed you by hand. Did I? Did I not? Well, you don't care. You all look at the calculator and it'll do it, right? Anybody, everybody good?
You showed me in the lecture on the video.
What's that?
I don't remember you showing.
Yeah, I don't think I did. It just occurs to me, I just ran around and made sure y'all had calculators, and y'all did, so I just said, all right, forget it. I won't show the by hand. Right? So you're all good? I still won't show it. No calculator? Oh, okay, I'll be glad to do it. All right, so the P thing, you start at 10, and you do 3 numbers. Yeah, that's it. You don't divide. Just start at 10, do 3 numbers. So start it, so the first, it's 10, it's 10P3. 10P3. So you start at 10, do 3 numbers. So 10, 9, 8, that'd be 720. Answer B. And then when they do the C, it's almost the same. Here, I'll change the color. For the C, you, what's going on there? Come on. Start at 8, right? Because it has an 8 first. Start at 8. Do 5 numbers. So it looks, so it's 8, 7, 6, 5, 4. Looks kind of the same. Start at 8. So whatever your first number, that's what you start at. For the P or the C. Second number is how many numbers? So, right? Is that making sense? So the first is always what you start at. The second number is how many. You go down by 1 every time. How many? But the only difference is for the C, you cut it. That's how I try to remind students. C is a cut. You cut it. You divide it by the second number factorial. So divide this by 5 factorial. I remember what that means. 5 times 4 times 3 times 2 times 1, right? All that means the factorial, the exclamation point, means all the way down to 1. So I could do this by hand pretty easy. 5 and 4 cancel. 3 and 2 cancel 6, huh? So answer 56. Calculator will give it to you straight. So there it is. You just start at the first number, do the second number of numbers. For the P, that's it. For the C, you cut it. You divide it by the second number factorial also. All right, now you got. Okay. 4 drivers in a race. Odds makers, probably drive A will win. It's 0.4. Other equal. Okay. So this is like the homework problem we had with the 01, 02, 03, 04, 05 kind of thing, where you got to like put the decimals and the X's and add them up and all that. Let's do that. So we've got A. Let's just scribbly A. Got driver A, driver B, driver C, and driver D. And probably for driver A, it says is 0.4. The other 3, that'd be B, C, and D, are all equal. I don't know what they are, but they're all equal. So what am I going to call them? X, X, and X. You add all those up, and what does it have to equal? 1.0 decimal, 100%, 1.0 decimal, right? We're in decimals, 0.4, so I'll just go with 1.0. Does that make sense? Because that's everything that can happen. Somebody's going to win that race, right? It's either going to be A, B, C, or D. So there's all their probabilities have to add up to 100%. That's like saying, yeah, you know that, right? So it adds up to 100%, right? So then I got to solve for X. So remember a little bit of algebra stuff. What is X plus X plus X?
X3.
3X, X3, either way. This is 1.0 over here. How do you finish getting X alone? Subtract the 0.4. So 3X equals, was that 0.6? Because 1.0, like $1 minus 40 cents. right, 60 cents. Last step to get x alone, by 3, x is 0.2. X is 0.2.
It asks for the probability that B won't win this. So we just add up whatever he doesn't have.
Right, yeah, so everybody good to there so far? We all good, x is 0.2. Now what is x? What is x? Well, x is the chance for B or for C or for D. It's the chance they'll win the race. So what's 0.2? It's the chance any of those three will win the race. What are they asking me for? That's where we got to be really careful. See this very small and very important word? Watch out for the knots on the test today. That really is important, huh? What's the chance that B will not win the race?
0.8.
Yeah, if there's a 20% chance of rain today, 20% chance that 0.2 chance that B's going to win, not B is 1 minus the 0.2 is 0.8. Is that good? That makes sense on that? It's the opposite, right? Whenever they say not. Okay, 21. What are the odds that D will win? Odds. So at least they're not saying not this time. They're just saying D's going to win. So the chance, first off, the chance for D to win, it's 0.2, right? Because D's just another one of those X's, and all the X's are 0.2. So D to win, the probability, that's the probability that D's going to win, is 0.2. Now, how do you turn that into odds? Odds for D. How do you remember how to turn probabilities into odds?
And we put it into a fraction.
Yeah, make it a fraction. Exactly. So how do you turn this? Let's go back to this 0.2. 0.2, let's make it into a fraction. How do you turn 0.2 into a fraction? Yeah, 2 over 10. We okay with that? Because that's, right, remember the decimal place is the first place after the decimal is the tenths place. So that literally is 2/10, right? And then reduce that, divide by 2, and that is 1/5, right? That's the probability. I still don't have the odds. That's the probability that D's going to win the race, 1/5. Now, remember, so probability is 1/5. Remember what probability is? It's 4 over total. And remember, odds is for and against. Remember that? You want to have that in your card today. Probability is 4. So they start the same. It starts with a 1. You write the word 2 in the middle. It starts with a 1, right? Probability and odds both start the same. They both start with the 4, the number of results that are for what you want. Probability ends with a total. Odds ends with against, like a debate, for and against. So if 1 is for it, how many are against it? Out of 5? 4. 1 to 4. We okay with that? Right, because there's 5 total, right? Right up here. 5 total. Probability was 1/5. 1 result 4 out of 5 total. So the odds is 1 to 4. Because then if there's 1 for it, there must be 4 against it for 5 total.
And because A is 40%, so that's kind of 2.
That's true.
Yeah.
Is that okay? That make sense? You okay with the odds probability thing? There'll be a couple of those on the test today. So odds is, well, probability is 4 in total. Odds is 4 and against. Right? They both start the same. They both start with 4. But they end with total for probability and against for odds. And so you always, if you get a decimal, you always have to turn it into a fraction so you can change it. Right? Any other questions? You guys are giving that one funny looks. Anything else I can say to help on that?
So once you get to 1 out of 5,
Yeah. So once I had the 1 out of 5, so yes, I took the the probability for D was 0.2. I converted that to 2/10, reduced it, got 1/5. That's still probability. So then I think, okay, what is that? That's 4 over total. Just always remember probability is 4 over total. And then I think, okay, and now I need to do odds, the odds for D. And how are odds different? Instead of 4 in total, they're for and against. So if there's 5 people in a room total, and 1 is for D winning, how many are against D winning? 4.
okay.
So that's why it's 1 to 4. Does that make sense? 5 total in the room. One result is in favor of D. The other 4 must be against D. 5 total. Is that good? So odds is 4 and against, which probability is 4 in total. Convert to a fraction. Good. So I think 22, we'll try that again probably, huh? 22. Chances of rain tomorrow, 20%, and then the odds of rain. Yeah, that's good. Can you do that one? So we just did one. Let's try another one. See if it's getting easier. So what do you got to do with that 20% first? Make it a fraction, huh? So make that a fraction. So 20%, that's 20 per 100, huh? That's what percent means, is per 100. So then reduce that, divide top and bottom by 20. And you get 1/5. Or you could have just made it 0.2, and then it's 2/10, it's 1/5. One way or the other, get to 1/5 eventually. So and that's what? That's the probability. And then we're just converting to odds. So what are the odds going to be? So probability is 1/5. So that's 4 total. Remember, probability is 4 in total. Odds are 4 and against. So it's just like the last one. If there's 4 out of 5 total, there's 4 against. It's 1 to 4. Now, they don't have that answer there. Well, it's the same as 2 to 8. Yeah. Do you realize it's just like a sideways fraction? Does that make sense? It's just like 1/4, huh? Which is the same as 2/8, isn't it? Make sense? You okay with that? Would we be able to not be fooled by that? I don't know why they didn't reduce it. I get these answers off the publisher's thing, but it's the same answer. Question, Janet?
Yeah, I think where I'm getting confused, I understand it, but it's when you get the 1/5, and then how you get it, 1 to 4.
Right.
How does that happen again?
Yeah, because the 1/5 is probability, and so probability is 4 over total. So imagine like a room of people, 5 people total in the room. 1 is for the thing. So how many are against it? The other 4. And that's what odds is. 4 and against instead of 4 total. So it's like there's 5 people in the room. We say 1 out of 5 are for this thing, which means it's 1 versus 4 people, which is what odds says. Odds says tell me how many for and how many against. Probability says tell me how many for out of the total. So that's the difference. You always want to be clear on that. Probability is 4 out of total. Odds is 4 and against. And then so 1 to 4 is like a sideways 1/4, which is the same as 2/8, isn't it? If you reduce the fraction to 8. So it's the same thing as saying 2 to 8. So that's why answer A is right. It doesn't have to be reduced. It's equivalent. It's the same thing. Is that good? I don't know. You might have thought, hey, they're trying to trick me. It's not reduced. None of the above. No, don't do that. They're not trying to do that. They're just, for whatever reason, they didn't reduce it. Oh, no. But it is equivalent. Is that okay? Good. Get a little more practice. All right, let's try 23. See how you're doing on 23. So they give me probability. Want me to change that? So what do you got to do with that probability right away?
Put in a fraction.
Make it into a fraction. So go ahead and see if you can do that, okay? Some of your calculators will do it automatically. You guys know how to do that? Yeah, just put that in 0.125 for you TI people. Put in 0.125. And 0.125. Oh, you can go ahead, yeah. 125, and then hit math button, and hit enter. Just change it automatically. So Here's will do it, here, up here, the changes fraction decimal. Oh. 125, second there, fraction decimal. So we'll do it. So a lot of calculators will do it. Did you find it on yours? Math enter enter. You find it at the top of the probability button? So you would do like, yeah, what about, and then hit second, here, see above the pyramid is the FD, let me change fraction decimal, second pyramid, and this is when we change it, yeah. There it is, we'll do it. So you know how to do it, right, with the SD button? Yeah. Right, so you can only do that by hand or by calculator, I'm doing here, with the math enter. Yeah. Same thing, good? Guys, good? Oh, I never know the cashier. I'm sorry to catch that. I'm uninformed about that. It's tricky. I like it, but it's tricky. Oh, there it is. Just that FD right there. Oh, yeah, I got this. So I think, let's see. 1, 2, 5. Let's hit this. What's happening? What's this thing always does to me? What's it doing? Do that. It's FTD, isn't it supposed to change between F function and decimal? Oh, there it is.
Yeah.
Oh, yeah. Oh, it's doing it. It just kind of does, it's weird it does that.
Mhm.
Yeah, that's nice. Okay. Yeah, there we go. All right, I figured it out. All right, did you get yours?
Yes.
PRB button. All right. So, yeah, so just change that right away. So take that point 125 and change it to an eighth, right? By hand, it's a little bit of work. By hand, I'll show you by hand if you're interested. It's 125 over what? Well, you got to remember the names of the place values. What's the first place after the decimal called? Tenths. Next place is the hundredths. Next place is the thousandths. Just goes up, there's no zero. So therefore, this is really 125 thousandths, isn't it? Tenths, hundredths, thousandths. And then you just got to reduce that. Just divide by 5. Top and bottom get 25 over 200. Then divide by 25. It'll be quicker. Be 1/8. So one way or the other, get to 1/8. So now, that's still just probability, though, right? That's still 4 and total, isn't it? That's still just probability. That's not odds yet. So when we change to odds, remember the difference. The whole room, instead of how many are for the issue out of the total room, it's how many are for and against. Like a debate. They break into their two sides, so to speak, like in a debate, right? For and against. For and against. So if there's one, and they start the same, remember, odds probably start the same. They both start with 4. So how many must be against? Must be 7. We good? So there it is, 1, 2, 7. 8. Okay, and then, that good? Go on to number 24. You okay with that one? Okay if I flash ahead? Number 24. Suppose that the odds of winning, the odds, now they're starting with, notice this, they're starting with odds. Odds are 1 to 7. Change that back to probability. So that's odds. So that already is for and against. Odds, they're at odds. Yeah, that's a good way to remember. They're at odds. They're in a debate, right? For and against, they're in two separate groups. And you want to change that to probability, which is 4 over total. So that's 1. And what's the total? Got to be 8, because there's 1 and there's 7, huh? 1/8. Is that none of the, oh, it's A. Option A. That good? We happy with that? And then 25. Answer the question based on the following. 250 students, math class, take the final scores, have approximately normal distribution. What does that mean we're going to do as soon as we read those words? The bell curve, right? For sure. The normal curve. Seeing bell-shaped curve. All right, so let's do it. So I'm going to put a bell curve here. You have a bell curve on your 3x5 card, right? So right in the middle. And then 3 jumps, 3 lines to the right, 3 lines to the left. And the one in the middle, now what goes in the middle? Well, they're telling me the middle, the mu, They're telling me up there 75. This number right here, that's the middle. So the middle of that thing is 75. Put that right in the middle, huh? And then the standard deviation, what do you do with the little sigma squiggly standard deviation thing? That's how much from line to line, jumping right and left. Yeah, so add 10. So this would be 85, 95, 105. Just keep adding 10. And the other way, you subtract 10. This would be 65, 55, 45. And then now the percentages are always the same, aren't they? 34%, 34%, 13.5%, 0.5%, 2.35%, and 0.15%. 0.15. Yep. So there's all those percentages, all filled in. Okay, so now, let's see if we can answer their questions. They say approximately 95% of the class scored between blank and blank. Well, we could just try it out. What's their first one? 45 and 100. 45 would be right here. 100 isn't even one of my numbers. It's not going to be 100. That's just wrong. So I'm going to skip A. Why? Why do I know A is not right? 100 is not even one of my numbers on the bottom there. I have 95 and 100. It's not going to be A. Go on. It's not B. Not. Look. It's not C. It's not. Wait. I'm going too quick. It's not B because 0. I don't have a 0. No way. Is it C? No. Look at C. C only goes from 65 to 85. What percentage is between 65 and 85? 34 and 34. 68. That's not right. That's not 95, right? They're asking me for 95. So it's not that. No. So it's not A. It's not B. It's not C. Maybe it's D. Between 55 and 95, from 55 to 95. Is that it? That's, why did I erase that? 13.5. That's it, huh? 13.5, 34, 34, 13.5. If you add those up, 13.5, 34, 34, 13.5, you'll get 95%. It's D. 95% are captured between 55 and 95. Does that make sense there? Just add those percentages up on your calculator. 26. Approximately what percent of students score between 65 and 75? Okay, so 65 and 75 is from here to here. 34%. B. Right? 27. Peter's score on the exam places him in the 16th percentile. What do you get? Now, what does that mean? 16th percentile. What if you take some exam or got a baby's weight? 16th percentile. What does the word percentile mean? Percent below. Below. So you got to know that clearly. Percent below. Percent below. Write that on your card if you're not 100% clear on that. Percentile. So 16th percentile means 16% below. So they're saying what spot on that curve, and below means to the left, huh? That question then is saying, hey, what spot on that curve has 16% below it to the left of it? Let's try it out. Is it 45? Here's 45 right here. What percent is below 45? 0.15. That's not even 1%. Right? It's 0.15 of a percent. So it's not 16%. No. B, 55. Is it 55? What percent is below 55? whatever 2.35 and 0.15 add up to be, it's not 16, clearly. Keep moving. Is the answer just straight 16? No. Is it D, 65? If you're at 65, what percent is below you? Yeah, if you add those up, those three make 16%. So the answer is D, 65. At a score, that must be Peter's score. He must have got a 65 because 16% of the class got below him. He would be hitting at the 16th percentile. Does that make sense? Percent below, percent to the left. Notice how all the percentages are up in the curve, so the numbers on the bottom are the non-percentages, right? So when they tell us 16th percentile, we look for 16% left on the curve, and we find the number on the bottom that corresponds with that, 65. Good on that. And 28, Carol scored 85 points on the exam. What's her percentile? So she got 85. Carol got an 85. So Carol's right here. There's Carol, right here at an 85. So what's her percentile? It's percent below or left. Right? That's what percentile means. So what percent is below Carol? Well, all of these. All of those are below Carol, because she's above average. So all those are below her. So you add them all up. Now, the easy way to add them all up, from the middle, from here to the left, is half the curve. Must be 50%. Plus 34, 84%. Does that make sense? Half the curve is 50. So she has this section, 34, and then half the curve. She has 34. You can just add them all up by hand if you want, but I mean, that's the quick way, right? She's got the 34%, so she got this section. Carol's here. So what's left of her is a 34 section and then half the curve. Right? It's 34 section plus 50%. Right? Half the curve is 50%. Does that make sense? Questions I can answer on that? So she's at the 84th percentile. Questions I can answer? Is that confusing? You guys don't look very happy about that. Jenna, can I ask her a question? Can I answer a question?
Oh,
Any
yes.
questions? Is it good?
So she's at the 85, right? And then you said that it's half?
Well,
That half plus?
Yeah, so if you look at everything, you're right, she's at the 85, so I want to add up all these to the left. And so that means the 34, and then this is half the curve from there. So the easy way to add them all up is just to say, look, from here left is a section of 34, and then there's half the curve, which has got to be 50%. So it's got to be 34 and 50%, which has to be 84. I mean, you could just add them all up by calculator. You get the same answer. I'm just doing a shortcut. Just saying, well, look, all half the curve is got to be 50% plus the 34. Is that good? So percentile is percent below, percent of. That's a useful thing. Real life, people will use the word percentile. You want to know what that means. It was 75, jumps were 10. All right, I guess we'll do it again. So for more questions. So one more time. So the middle is 75, jumps are 10. 1, 2, 3 jumps to the right. 85, 95, 105, 1, 2, 3 jumps left. 65, 55, 45. All right, and the percentages are always the same. 34%, 34%, 13.5%, 13.5, 2.35, 0.15, Okay, now what's their question? Third quartile. What do we do when they ask us third quartile? We have a little formula, huh? We have a special Q3 formula. So coming down here, third quartile, we have a Q3, which is, what is it, mu plus 0.675 sigma, right? That's our formula. So just use that. You want to have that definitely on your 3x5 card. Right, we have the Q3 formula, and then the Q1 formula is the same thing, but with a minus, huh? So make sure you have those two formulas on your 3x5 card. So I'm going to use the Q3 formula, which is mu, which is the middle, plus 0.675 sigma. Sigma is the jump amount, right? 10. So that's 6.7, that's 81.75, rounds to 82. B. B, 82 on that. Okay, C. No, I mean number 30. Approximately how many students got test scores between 60? Oh, that's a harder question. Oh, they're being tricky. Okay, let me do that one. Okay, you guys good with that? So I want to do number 30 now. 30 is tricky. I don't know if that one got you. 30 is pretty tricky. So for number 30, they're saying how many got test scores between, sorry, I just keep cleaning up the graph here. Between 68.25 and 85. So how many got test scores between 68.25 and 85? Well, those are not percentages, so I'm not looking up in the curve. Those are on the bottom. Here's the 85, no confusion there. But where in the world is the 68.25? I don't see it. Somewhere between the 65 and the 75. It's just not there. It's not there? How are we going to do this question? Nobody figured it out?
You add the two and divide by 2 to figure out what that middle is, between the 65 and 75.
That's 7, right? Middle 65 and 75 is 7, right?
Yeah.
So that ain't right. That's not 68.25. So it's some weird number on a bell curve. Some weird spot on the bell curve. You know what it always is when you do a weird thing in the bell curve? It's Q1 or Q3. It's Q1 or Q3. That's what, it's either going to be one of those or Q1, Q3. So if it's not one of those, it's Q1 or Q3. Yeah, they're pulling out a Q1 or Q3. Now, tell me, 68.25, is that before halftime or after halftime? It's before the 75. It's before halftime. So do you think it's Q1 or Q3? That's Q1. That's got to be Q1. That is. You could prove it. You could do the little Q1 formula and plug in the 75 and minus 0.675 times 10, and it would come out to be 68.25. That still doesn't finish the question. I'm just proving to you my hunch is right. That is Q1. Okay, so what? So what? That's Q1. Well, it's about right here, right? The 68.25. It's Q1. Okay, so what? What does that mean? What does that mean when you're at, what if I say, where are you in that ball game? I'm at Q1. I'm at the end of the first quarter. How much of the game is over? 25% of the game is over, which means all of this to the left of Q1 is 25%, right? That's what it means to be Q1. To the left of you is 25%, right? Okay, so what? Well, this is halftime here. So how much is right? Let me do a different color here. How much is right in here? How much is from the end of the first quarter to halftime? Another 25. Right there. Right? You with me? Am I losing you? A couple logical steps. You see that? If that's Q1, and how, you might wonder, how am I going to know that? Because whenever they give you a number that's not one of your numbers down there, look for Q1 and Q3. That's all they're going to do. If it's a number that's not down there, it's Q1 or Q3. It's before the halftime, so you know it's Q1. And then you know what that means about the percentages, right? Q1 is the 25% of the way through the game thing. So then how far from Q1 to halftime? Another 25%. Okay, so what? Well, they want me to find out how much between 68.25 and 85. Where's 85? Here. So how much from here to here is what they want. What percentage? 25 in this section, 34 in that section. 25% plus 34%, 59%. We're almost done. We got one more step. Is that good so far? Do you see that? How I did that? Right, we're cutting into this 34% section. Right? Cutting into it with a Q1. So left of it is 25. From here to the middle must be 25. That's what it means. From the first quarter to halftime is 25. And then the next section is 34. So between this and this must be 34 plus 25. 59. Now, they didn't ask for the percent. They said, how many students? This is a tough problem. How many students? So how do you turn that percentage into the actual number of students? That's just the percentage. 59% of all the students. Yeah, you got to multiply by the number of students. How many? Was it 250? What did it say?
250.
Yeah, 250. So then you just now you need to take that 0.59 times 250. So we got it? What is it? 147 and a half a student, huh? So I guess we'll just round it to 147. Yeah, don't, it says, notice it says the word approx. Yeah, don't be tricked on this. I don't want to trick you. I'm just getting these off the publisher's webpage. I'm not trying to trick you. It says the word approximate. So don't think, oh, it's 147.5. I'm going to choose none. No. It says approximately. So 147 is close enough. 148 would be fine also. Probably even 150 would be a keeper. I mean, anything really close is good when they say the word approximately, right? So don't choose none of the above. We good? We happy? Feel better about that one? So watch for Q1 or Q3. Well, we're using up all the time. We got to keep moving. That's tricky. So I want to do 34, then I want to show you that other one and we're done. All right, I'm just going to do 34 here because that's the trick one. I don't know if you work through this. Another one of these things, bell curve, blah, blah, blah. You know, the middle is, what do they say, 610, right? I'm looking right here. Here it is, the mu. The mu is always the middle. The standard deviation is 60. So we're jumping by 60 each time. That'd be 670, 730, 790. 3 jumps left. Down by 60, what's that, 550, 490, 430. Y'all see what I did there? Right, just put the middle. The middle is 610. Right in the middle is 610. And then jump by 60, add 60, add, right, just keep adding 60. Okay, anyway, question 34 says, how many scored more than 570? Notice 570 is not one of my numbers. 570 is between 550 and 610. It's not there. What does that mean it is? It's Q1 or Q3. Now, how do you know whether it's Q1? Was it before halftime or after? It's before. It's Q1. It's Q1 again, isn't it? It's Q1 again. They're doing it again. So that means Q1 is here at the 570 mark. That must be Q1, which means what? All of this is 25%. That's the end of the first quarter. Between here and here is another 25, right? Between end of the first quarter and halftime, right? You know the rest of the percentages, 34, 13.5, 2.3, 5.15, all that same stuff. What's their question? More than 570. More than 570. Well, here's 570. It's the end of the first quarter. So at the end of the first quarter, how much more of the game do we have to go? 75% more, right? More than Q1. Does that make sense? Because it's 25, and then this is half the curve, 75. But then you got to turn that into the number, because they're saying how many, right? Whenever they say how many, you got to multiply by the number of students. Was that 4,000 students? I can do that. 3,000, right? 3/4? B, 3,000. Is that okay? You see the trickery they're doing with the Q1? Right? Everybody see how I'm identifying that? When they give you a number, it's not always put your middle number and add, subtract, the standard deviation, right? And then when they give you a number, 5 cents, they're supposed to be the numbers down here. When they give you one that's not there, you know it's Q1 or Q3. And what does Q1 mean? 25% to the left of it, 75% after it. Or you could say 25% between there and halftime, right? It splits the left side into 25-25. Q3 on the right splits the right side into 25-25, right? Good? All right. Honest, dishonest, coin, flipping thing. Remember, we just had a formula. I just want to remind you of that formula. So if there's a problem on the test day, I'm sure there is, about rolling a die or flipping a coin or something like that, and they say this, and this, and then they say, find the mean. Remember, I gave you a formula. It's N times P. Put that in 3x5 card if you don't already have it. It's N times P. This is N, the number, and P is the probability of whatever, 2/5. So it's going to be N 1350 times P 2/5. And so crank that on your calculator. 1350 times 2 divided by 5. Is that what it is? 540. There it is, D. Everybody good with that? Remember that formula I gave you? That's for when they're flipping a coin or rolling a die or doing anything random. And they ask you for the mean. And then I also gave you a standard deviation formula yesterday. Down here, standard deviation. Sigma equals the square root of N times P times 1 minus P. Remember that one? Have that one on your 3x5 card also. There's certainly a problem on today's test where you're flipping a coin or rolling a die a bunch of times, like 1,350 times. And there's a probability of something. So you got an N and a P. So the mu, the middle, is N times P, and the sigma is the square root of NP times 1 minus P. So here we go. What is N? N is the same thing it was a minute ago. 1350 times P, which is 2/5, times 1 minus P, 1 minus 2/5. Can you put all that into your calculator underneath the square root? Or you could actually do it first and then square root it after, whichever way is easier for you. And I'm trying to figure it out. I can't. Yeah, I don't know. What is it? I got it? What is it? 18? Okay.
Yeah, 18.
18, y'all able to do that with your calculator? If you have trouble doing that with your calculator, come up here in just a minute when I hand out the test, and I'll be glad to show you how to do that on your calculator. So, 44. What are the chances that x is 540 or less? Well, now that I have a mu and a sigma, I could do a little bell curve, right? You get the idea? Now, you can do a little bell curve. This is another bell curve. The middle is the mu, 540. And there's 3 jumps to the right, 3 jumps to the left, and every jump is 18. That's what the sigma is, right? So we found our own middle and our own jump amount using those formulas. So now you just add 18. This will be what? 558. Add 18. 578, 576. Add 18. 594. The other way you subtract 18. 25, 22. Subtract 18. What's that? 504. And subtract, just keep going. The percentages are always the same, right? Percentages are always 34%, 34%, 13.5, 2.35, 0.15, always the same. And then what's their question? 540 or less. 540 or below. 540, that's right in the middle. Right? 540 is right here. 540 or below, what percentage is that? 50. It's half the curve. It's exactly half the curve. Is that good? 45. What are the chances that it's 522 or less? What's 522 right here? Right, that's why I found the numbers, right? Every see what I did? I used the formula to get the mu and the sigma, the middle and the jump amount. Put them on here, right? And there's the 522. They're not being tricky. They're giving me one of the actual numbers, so it's not a Q1, Q3. 522 is right here. And it says or less. That means left of that spot. So it'd be 13.5, 13.5, 2.35, 0.15. Add that up. That's 16%. C. Is that good? So there'll certainly be one on the test today where you're given some dice or coin or something, done a bunch of times. Use the formula to get your own middle and jump amount, mu and sigma, and make your own bell curve. The percentages are always the same. And answer their questions. All right, I think we've all had enough, haven't we? There it is. There's math 45. I hope this is the big acer for you. Carry you through to that grade you want to get.
Do you know about the transcripts will be sent out, like, can I get it sent out, like, next week, or?
Yeah. What's up?
Oh, it was on Monday, so
Great. Yeah, I'll turn them in probably by today. So, but they won't, that doesn't mean the office will crank them out that quick. Yeah, so as far as getting your grade, knowing what it is unofficially, by 5 o'clock today, go on the mathexcel.com, and you can see your grade. I'll put the 5th exam in there. You'll have your total grade by 5 o'clock today, and then I'll turn them into the official system. It takes them usually, I don't know how long it'll be. Give them a call. Just call the admissions office and say, hey, how long till grades come out officially like? They'll let you know.
Will do. Thank you.